And hi everyone, we are from Faculty Electrical Engineering Section 1. This is my group members Amira Syaqira, Norrini Bt Samsi, Siti Aisyah and me Shakilah Ismail. So today we will look at how the series resonance circuit worked. So first and foremost, this is a circuit that given to us. Here voltage source, resistor, inductor and capacitor. So in order to get the equation, we use Kirchhoff's voltage law. So from that we get negative Vs plus IR plus Ij omega L plus I 1 over j omega C equals to 0. Then we rearrange the equation, then we get I bracket R plus j omega L plus 1 over j omega C equals to Vs. Then we make it Is as the subject. So we get Is equals to Vs over R plus j omega L plus 1 over j omega C. So we substitute this particular equation with zt. So finally we get Is equals to Vs over zt. So now we have to find equation for frequency responses, which is Is equals to Vs over Zt. Zt equals to square root R square plus S square equals to R square root R square plus bracket omega L minus 1 over omega C square. So we get Is equals to Vm over square root R square plus omega L minus 1 over omega C square. So now we can see by using the MATLAB. Here we go this code, and this is omega naught responsive frequency, Q1 and Q2 is quantity factor, B1, B2 and B3 is bandwidth. So we have to substitute the value of the resistor with 40 ohm and run the program, and we get the graph, and now we see the calculation. Omega naught we get 111.8034, Q1 is 0.5590, Q2 0.5590, B1 equals to 200, and we can see this graph, we can get the omega naught, which is equals to 112.7, which is approximately to the omega naught from the calculation, which is 111.8034. So now we have to substitute the value of a resistor for quantity factor 2 with 60 ohm and run the code again, and we get this graph, and the calculation would be omega naught 1 equals to 111.8034, Q1 equals to 0.3727, Q2 0.3727, and B1 300. And now we see the graph, and from this graph we can get omega naught. And the value is 107.7, and which is approximately to the omega naught being calculated, which is 111.8034. So now we substitute the value of R with 20 ohm for the quantity factor 3, and we run the code again. We get this graph and see the calculation. We get omega naught equals to 111.8034, Q1 equals to 1.1180, Q2 equals to 1.1180, and B1 equals to 100. And as we can see the graph, we can get the omega naught, which is 112.7, which is approximately to the omega naught 111.8034. So now we can discuss about the function of the series resonance circuits. We have 3 points here. The first point is series resonance circuits are one of the most important circuits used in the electrical and electronic circuit. Second point can be found in a various forms such as in AC mains, filters, and also in radio. Also used in television tuning circuits, producing a very selective tuning circuit for the receiving of the different frequency and channels. And we have table here, which is to compare the three quantity factor, which is initial quantity factor Q1, which is 0.5590, and the second quantity factor is 0.3727, and third quantity factor is 1.1180. And from the so we can conclude here that the best selectivity of the circuit is Q3, which is 20 ohm with the quality factor of 1.1180. And the quality factor of a resonant circuit is the ratio of its resonant frequency to its bandwidth. A resonant frequency is designed to operate at or near its resonant frequency. It is said to be high Q circuits when its quality factor is equal to or greater than 10. Thank you, and that's all from me, and don't forget to like our video.